Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video, part 4 of SpotMicro, we're going to look at wiring up some of the electronics. So when looking at all of this, it occurs to me that I may have to pull the instrument tray or the base tray out with all the electronics on in order to plug some of the plugs in. Once the legs are on, this obviously can't be done because you can't get to the screws past the legs. So I've got a few ideas on what we're doing here. Now I pulled out 4 of the screws and pulled this side plate off, and then I cut a hole in it to line up with the micro SD card on the Raspberry Pi, because I worked out that there was no other way to get the SD card in once the thing's assembled, short of pulling the Raspberry Pi itself out, which I wanted to avoid if possible. While I had that side plate off, I also fixed up the spinning nut from the last video. I'd missed both the nuts on one end, so that's now all done. So I've got these these JST connectors. I got this kit some time back. I've actually got a second kit of connectors because they're useful and I'm running low on these pins, and they just crimp on. And I've got this 16-way ribbon cable that I've been using for small links and jumpers. So I'll be using this for all my signaling wires, and I'll use heavier wires for the power. On the header of the Raspberry Pi down this end, we've got a cluster of things that we're going to be using, and for that I'll bring up the PDF or the image file that I've got that shows the pinout. So pin 1 is 3.3 volt power, and we can use that to power the MPU 6050, and there's actually 2 power sources on the PCA 9685. One power source is the V-in, which is supplied to all of the servos for their power, and the other one is VCC, which is powering that little chip in the middle. So we can power it with 3.3 volts and they work fine. So we'll use the 3.3 volt on the I2C bus. Also on that same line we've got so we've got our 3.3 volt on our pin here. We've got SDA, SCL, then we've got a GPIO4, and then we've got a ground. So we need that ground, the 3.3 and the 2 I2C pins. On the other side we've got 2 lots of 5 volt, so we can actually feed 5 volt into the Raspberry Pi there, and the associated ground that we also need for that feeding power in. Then the next 2 pins are TX and DX. Now this is the TTY serial, the hardware serial on the Raspberry Pi, and we can use that to link back to the Arduino Nano, and that means that we don't have to worry about a serial wire between this point, which is going to be pretty tight for space when trying to get a serial in. There's pretty much no room there, so I don't like my chances of getting a serial plug in there. If I wanted to access that down the track, I'd have to put a hole through for a serial connection. So that way we can wire directly over and connect to the serial on the Nano and not have to worry about the USB side of things. We also need to make up a plug to connect the connections to our ultrasonics down the front eventually, and we also need to supply power, and it needs 5 volt as well. So we can jump the 5 volts from here across. We're going to have to do some joints in our ground wire, but that's neither here nor there, and I will probably have to do a join somewhere in my I2C. So one of these plugs will go onto here. I'll have pin pins in there, obviously. That'll come across. We'll have this one on here with the I2C bus hooked up, and then it'll come across onto this one, and we'll connect to the I2C pins on here as well. Now we can grab power from the V plus here, which is the higher voltage, and we can actually use that to feed power to the Arduino Nano on the V in pin, and that gives us a lot of options in as far as power distribution. So we can either feed 5 volt from here into the 5 volt on this, or we can use the high voltage from the servos. I'll make my final decision at the last second on that one. So the reason why we want this as just a 2-pin plug here is so that we can unplug it, because if we have to update the firmware, we'll need to unplug it in order to do that with the USB. There's a little bit more room there, so we might get the USB plug in. Alright, so with all of that brief explanation out of the way, now I've left this side clear. There are pins on it. I could come back over to here, but in the back part of the robot, we've got provision for the switch, and we've got provision for this 2-line LCD display, and that sits in here. And that's also I2C, so I want to make up a plug that goes from there into this so that I can plug it in. This obviously won't go on until after the legs are attached, but I do need to make provision for it and probably set up the wires, plug them in. So let's start by making up our first I2C bus, and that'll go from this, and I think we'll just take it all the way around onto this and then back onto here. Now for this you will need a crimper. I've had this one for a while. I picked it up from Banggood, I think it was. Makes it very easy to do these. Now, if you've followed my channel for a while, you've seen me do a few of these already. Okay, so I'm going to use red for VCC. That's our 3.3 volt in this case. I'm going to use brown for the ground. Clock and data. Let's yellow for the clock. Yeah, yellow for the clock sounds good. Okay, so they're all in. I don't want to go under, I'll go over and back in over here. So that won't have been the best video image, but I really do need to see what I'm doing with these ones because they are a little more challenging to do. And that didn't take. came undone, so my crimp obviously didn't take. There is another way I can do this. I'll try once more with the crimp. No, I don't think that's going to work. Alright, I'll switch to the other method. Okay, so the other method I can use is to use one of these. They're not as good as these, but when you've got two wires going in, it can be a lot easier. So you get one of these go into a print circuit board and get soldered in and give you the female slots. So they plug straight on like so. Okay, so that leaves the power to be done for both the Arduino and the Raspberry Pi. I also need to get power down to here at some stage, but that'll come direct from the switch mode power supply. That should be powered from the Raspberry Pi anyway, so that's done. I do need a ground point coming back, so we'll need to find another ground point at some stage. Okay, next thing we need to consider is the LCD display at the back. For that I'm going to use this short piece of 4-core ribbon and connect that to a 5-way header. Since this one I only had 5 pins connected, that was to prevent accidentally connecting to the V+. And then the 4-pin on the LCD display itself. So let's get to that one. Okay, now we need to consider the ultrasonics at the front. So I've got this 6-way header. If I stagger it off 1 pin from the last one, so that's a reset line that I'm not using, I pick up a ground and then D2 through to D7, I think it was, D6. Yeah, ground D2 through to D6. Now I need power to run the ultrasonics, and they require between 10 and 20 milliamps of power at 5 volt. The Arduino Nano can output up to 40 milliamps of power on an I/O pin. So we can actually power our ultrasonics as long as we're only driving one at a time, which we should, because driving 2 would confuse the signals. We should be able to run the 2 ultrasonics and be able to turn them on and off. So that's what we're going to do. So this is a front housing for the ultrasonics. I'll pull one of the ultrasonics out, and we have our pin definition here. So we've got ground, echo, trigger, and VCC. So if I use brown as our 0 volt, red as our 5 volt, I can then use the orange and yellow as one of the ultrasonics and green and blue as the other ultrasonic. So that's what I'm going to do. Okay, so that only leaves the power supplies left to do, and I think I'm going to have to modify this a little bit to mount my 2 switch mode power supplies in. Probably drill a hole through for these screws to go through and be embedded in. So I might do that off camera because it's going to be fiddly, and then come back. So the red and black wires here will be connected to the outputs of one of these two, and I'll get another pair of wires, probably use brown and yellow or brown and green, to come up the other one and go into these terminals. The inputs of these will just be connected to in parallel and then off to the switch. The switch is this one and mounts directly into the back of this, and that's the main power on and off. The LCD display gets mounted in here, and what I'll do is drill 4 holes which line up with the screw holes here all the way through, and I'll use little brass standoffs with some spacer washers to just hold that flush to the back instead of poking all the way through. It'll look better, it won't get damaged if it falls over. All round it'll be a better setup. If you look at that now, pushed up flush, you can see that it is actually at an angle, and that's because when you look at the display, one end has the backlight. So we need to stand it off to allow for the backlight. So I will do that probably in the video after I do the leg, attach the legs. So that'll do for this video. If you like these videos, don't forget to click on like, comment, subscribe, ring that notification bell so YouTube will let you know when further videos come out. It's also a form of support that costs you nothing and helps the channel a great deal. If you want to help the channel further, I do have a Patreon account. There's a link in the description, and you can join my VIPs Go Lucky and Lorenz Berger, and my other Patreons, Elmerels45 and Ratchet. Also a link in the description for my Discord server, where I have a growing community where we discuss different aspects like the Spot Robot Dog. You might be able to make suggestions or learn a bit from it. And we'll see you in the next video.